can not only write vectors as a magnitude and a direction, or using side carets with horizontal and vertical components, you can also write them using i's and j's. The i's and j's, guys, it's just another notation. It's called linear combinations. I'm going through and adding little arrows to all my vectors to remind you guys that's what you should be doing. But I don't put them in the beginning because in the book they're not going to put them in the beginning since they can type in bold. But once again, you're not allowed to write in bold. Okay? One way to write W. One way to write W is with side carets for -5. From what we did at the very end of class yesterday, how can you write the vector using linear combinations, aka the i's and j's? For I, not plus, minus. Why minus in this case? Because the 5 is negative since the vector is going down. Does that make sense? The plus of the i's and the j's, technically, mathematically, in terms of physics, the i's and j's say they're not only distances, but they're vectors. Just, I don't know, makes it a little bit more specific. But as you guys can tell, is there really a huge difference? No. There's not really a huge difference. Just another way of writing it, okay? So if we go down below, and if we have this given u and this given v, and if they want us to find or do the basic operations on these vectors, they've given them to us in linear combination form with the i's and the j's. What do you guys think we're going to do with 2 times vector v? Exactly. Remember yesterday? Was it hard to multiply a vector by a scalar?
No.
No. So it's not going to be with linear combinations either. Take vector v, right? And just double. Double what? Double everything. The horizontal component and double the vertical component. Does that make sense? And this you can actually think of as distribution because we have a minus and we're distributing the scalar to both pieces. So the math, once again, is just as easy. You just have to make sure you understand the new form of the i's and j's, just separating the horizontal and vertical components. Okay, how about u plus v in linear combination form? What do you guys got?
4 equals 2j.
Good, because there's an understood 1 coefficient in front of that I, right? So add the horizontal, add the vertical, and this is kind of more what we're used to since we're used to algebra with variables anyway, right guys? Put the i's together, put the j's together. Yeah, you could also say that it equals, but my guess is if they're giving it to you in linear combination and not saying to transform it, they're expecting you to end in linear combination form as well. It's just the technicality of this one is showing the distances, whereas these ones are showing the actual horizontal vectors. So it allows us to be a little bit more precise when we're actually showing the 2 different vectors, that they're vectors going together like the vector addition thing. And we get to end with the unit vector, which some of you guys weren't totally tuned in for at the end of yesterday. Unit vector of which one? Of u, right? Let's go ahead and sketch u first. Let's go ahead and sketch vector u. Not vector v, sorry. We used the vector v. Sketch vector u. Kiddos, what quadrant would that vector be in of 1i plus 5j?
1.
How come?
Because it's positive.
Because you go right 1 and you go, both the components are positive, so that vector is going to be in quadrant 1, right? What is his current magnitude? Vector u, what's his current magnitude? You guys ever how to find magnitude? We can make a little triangle. We can see one side of the triangle as being 1, one side of the triangle as being 5. How do we find the hypotenuse? My triangle is not very straight. Yeah, just Pythagorean theorem. Some of you have already jumped there, but it's going to be 5 squared. To be precise, according to our formula, let me do 1 squared. plus 5 squared. 25 and 1 is 26. Do any perfect squares go into 26? Oh, come on, technology. 4 doesn't go into 26, almost. 4 goes into 28.
Nothing. Whoa.
Technology was not being my friend right there. Let's try again, take 2. Only I can figure out what to do. Oh.
Square hoops.
Well, square root of 26 doesn't break down anyway, though, right, guys?
No, it's hideous.
Oh no, I'm opening random things. Windows 10. Yeah. Okay. That's what I meant. Buddy.
Some people still use Windows.
Okay, hold on, let me get it back up.
Yeah, used to be India for like 10 years.
Go back.
The water's not working. Computer's not working. It's just a rough day, huh?
You should just all probably.
Good thing tomorrow's a minimum day. Let's put a positive spin on it.
I'm so happy.
This is so crazy.
I'm so
I'm
happy.
not necessarily sure if senior equate
Why are
wisdom.
you so cool?
The same way that junior doesn't necessarily denote foolishness, right?
No, it does.
Okay.
I want to get myself.
Just
I don't
look
know
at
if this year. I would. I know.
Ricky, is the focus today? I printed out my thing, and then I didn't put it in my bag.
Okay. For the rest of this week, which is literally like a day and a half, in this class, I only want to hear positive comments about each other. We're experimenting.
That's the most awesome.
You owe me a quarter, you owe me a quarter. We're gonna start a quarter jar for negative comments.
I don't think that's legal.
Oh, really? Pay attention, Mr.
Yep,
Campbell.
you lost.
Okay.
For breaking what rule? We haven't really
My
broken.
current rule of only positive comments for a whole day and a half.
For roasting.
Well, I won't be here tomorrow.
Let's
It's
do it.
really
Can we
like
do that tomorrow?
another
Today's gonna be
30 minutes. Or wait, when do we get up?
You're down. Oh, we broke it again.
When do we get up? 45 for another 30 minutes.
45.
Yeah,
for another
You're not
45
having
minutes in total.
Thank you guys for your patience. I know this is super annoying. It is to me as well.
You know what's super annoying?
God's trying to grow all of us.
You know what else?
I guess.
We should just get back
Four
to
hoops.
forever.
He's just looking at me and said something.
4 hoops.
We lost again, Ricky. Come on, Ricky.
Did you hear?
What are we doing? Unit
Software
vectors?
outside.
Right?
The end of draw now.
The first
Wait, what do we
non-massive
I didn't insult him. Yeah, but it's funny because he paid money.
Are they after that?
Oh, we're doing it in zip chart? That's a great idea.
It is a great idea.
That's a brilliant-
That's
That's a brilliant fundraiser idea.
Nathan,
That's kind of
how
like
many
break
games
all
have
of
you
our
played?
banks.
how many soccer games
A
have varsity
lot.
played?
All of us would be broke.
How
You
many,
guys assuming that
how
you
many
can't
games
handle
has
it?
soccer played?
No, we know that we can't handle
You
it.
should be
I
asking
literally, I cannot go.
12,
all day.
11,
Yeah,
and 1.
Yeah, 0-1-11.
Losses come or ties come last.
Yeah.
Yeah. 0-11 and 1.
Lit.
That's your record. 0-11 and 1.
Ricky, Ricky, in your picture is on the left side.
Alright, kiddos, here's the idea I want to try to get this to work. Guys, please be better than my Algebra 1 ninth grade students that hate math. Okay, come back. No, some of you didn't mind Algebra 1. Now, come on. There's a difference between the two. Here we go. Unit vector of u. We figured out what what vector u is from above, right? What is vector u? Vector u is 1i plus 5j. Then we talked about what the magnitude is of vector u, right? The magnitude of vector u, we did 1 squared plus 5 squared, square rooted. That's just Pythagorean theorem or the distance formula, however you want to think about it. And we ended up with root 26. My question to you is, this is all you have to ask yourself, is that 1? No, not even close. Come on, mental mathers. What is that approximately? Oh, come on. Where's
5
25? It's 5-ish.
5.05.
5.09.
We're guessing 5.0 something. But, hey, stop. It's 5-ish. Okay? 5-ish is not 1. So how do we find, nice. To find the unit vector of u, we need a magnitude of 1. To get a magnitude of 1, we have to scale back the old hypotenuse to be 1. How do we scale back the old hypotenuse to be 1? Jason, focus, bud. Divide by square root of 26. If we divide him by square root of 26, who else are we going to divide? Everything. So we're going to divide the horizontal, and we're going to divide the vertical. So you can think of, with unit vectors, it's as easy as find the current magnitude and divide everybody by it. Find the current magnitude and divide everybody by it. And kiddos, that's exactly what we did at the end of yesterday with the other unit vector in the other form. We found the current magnitude of the current vector. We divided each of the pieces by it. It just looks a little bit different. It's going to be a little annoying because the wording is going to stay as I scroll up, just so you guys all notice. But as we look at, I know, it's annoying. Some people are still writing it. But yesterday when we were finding the unit vector, which was up here somewhere, we found the current magnitude, root 74, and we said, hey, divide each of the components by root 74, which yes, you can rationalize, yada, yada, yada. Maybe the book does, maybe the book doesn't. But for this example, our current magnitude is root 26, and we divided each of the pieces of the linear combination form by it. You guys got it? This is disappearing, like that. Oh. Here we go. Next page. I need you guys to skip lines. Where? Let's skip lines here. Two lines there, and that's it.
Big line.
Skip 2 lines right there where I put them, otherwise you're just copying down. God is good no matter what. Man, it feels like it's consistent.
What?
I was reminding us that God is good no matter what. But
What was the second part?
it feels a little bit more like it right now since I'm computer screen.
Oh.
I didn't hear the entire second.
Okay, keep writing.
25 cents.
Put a quarter in it, it's jar.
You guys don't think I'm serious. I'm like counting bills in my head.
Intentionally pay a little money to
No.
somebody?
Yeah.
That's not the point.
You made so much. Here's $1. I got 4 free insults.
Yeah,
They're not free. If you have to pay $1.
That's so much money.
Well, yeah, but it's worth it sometimes if you've got a really good roast stored up.
That's
and
true,
you're waiting
that's
to
true.
use it.
Have to take consideration.
What's consideration for a mellow man?
Consideration
for your both.
That ended in like 8th grade with 2 Bushido.
Are you saying
Bushido.
You should bring Tuli back.
I miss Tool so much.
You know, I really don't know, because I learned nothing in like 3 years.
We just got you on video saying that. You got us on video, you know. I mean,
Alright, stop. We're done. Okay, you guys are writing down, and as you are, I'm going to go back to my normal notes because I just filled in the unit vector stuff all nice and pretty. Here we go. 12. Angle formed with the vector and the horizontal. We're trying to find theta. No big deal, it's the right triangle. No big deal, it's the right triangle. No big deal, it's the right triangle. So we have A as the horizontal component. We have B as the vertical component. If we're trying to find theta, it's no big deal since we have adjacent and opposite. So if I put opposite over adjacent, kiddos, what trig function should that equal for my angle? Tangent. How do I solve for theta? Yep. So theta is going to equal tangent inverse of both sides, which will cancel out the tangent on the left, and he will remain on the right. However, I told you to skip 2 lines because from time to time we need to check the quadrant of the answer that finds for us. We need to check the quadrant. Sometimes it is going to be in the fourth quadrant, and I want it in the second quadrant. Sometimes it is going to be 180 degrees away. So sometimes you're going to have to add 180. And if the problem wants a positive angle and it gives us a negative angle, sometimes we're going to have to add 360. Sometimes. Let's check the quadrant. Now the nice thing is we know how to graph vectors. Uh-oh. You guys show me that they're vectors?
Yeah.
You sure? Good. I is a vector, J is a vector, V is a vector. So we're going to use tangent inverse of B over A. However, sometimes we're going to have to check the quadrant with the vector picture. We're going to draw the vector and make sure the angle matches up. Oh no! Wait a minute. Do you guys see the difference? What did we just solve for in the first one? We solved for theta. What did I say we were solving for? To make life easier, let's just change this to B. I know I did it the wrong way. Solving for theta given A and B. I switched them. You guys see it? So then we're going to go ahead and cover in the next one. Let's solve for A and B given theta. You see it? I switched it. Solving for A and B given theta. Yeah, you might have to add 180 or 360 depending on the example. We'll try to get one for you. How do you solve for A and B given theta? That one's a little bit harder. We still use the right triangle. Let me get it to where you can see it. And we still use trig functions. But in this one, we have to actually say, you know what? Given just theta is not enough information. Hopefully we are given the magnitude as well. Remember, vectors can have magnitude and direction. That's one way of expressing them. So if you have theta, hopefully you have the magnitude as well. And I'll say beyond that, you should have the magnitude as well. So if we had the angle and if we had magnitude, which is the hypotenuse, we can use other trig functions that use the hypotenuse, like sine and like cosine. Sine and cosine, take theta and say, hey, let's relate it to the opposite over the hypotenuse. And let's relate it to the adjacent over the hypotenuse. And if we know everybody but the sides, we can just solve and say no big deal. So then B is equal to magnitude of B, sine of theta. A is equal to magnitude of B, cosine of theta. Only did one instead of two. Struggle. Box these are all important. And the only other formula you need to know is the one you already do know. R is equal to the square root of A squared plus B squared. But if you want to put it on this page and say, hey, these are all the important formulas of converting, it's not a bad idea. Not a bad idea. So plus 180 or plus 360, let's get an example. So all it has to do with the checking quadrant step. And technically we did it back in the day when we were, what were we trying to do? We were trying to find theta. We were solving triangles. It was chapter 4 and 5. It's going to do the exact same process, just now it's applied to vectors. Let's try to find an example. We'll go ahead to the next page.
Next.
Let me insert a page. Okay. Example. Let's do it this way. If I want to say find A and B, let's say find the component form. For a vector with an angle of 135 degrees. Nope, you guys are gonna actually use a unit circle for that. So do something awkward like 110. Got your calculators. And a magnitude of 5. They're just asking you to transform from one form to another, magnitude and direction going to components. And you'll see why we like components in just a second in the next example. So what are they asking? What about Ricky?
We're trying to find the two sides.
Yes, ultimately. Component form is taking the two sides and putting them into side carets. Linear combination form, taking the two sides and putting them into i's and j's.
Oh,
Is that cool?
Yeah.
So you guys are grabbing out your calculators. Because we just talked about this and we said, oh, no big deal. To find A, we use a formula, and to find B, we use a formula, right?
So
Okay. So A would be 5 cosine of 110. B would be 5 sine of 110, right?
Yeah.
We're calling this example A, so we're going to do example B in a second. Okay, what do you guys have for 5 cosine of 110? Degree mode, or else we're all in trouble.
Negative
Negative 1.7.
That's right, though. So negative 1 point what?
1.711.
Negative 1.710. How about 5 sine of 110?
4.6.
Good. So what does that mean? That means I can rewrite vector v in terms of components. Let's do the side carets for the sake of time. Negative 1.710, and then the vertical component 4.698. Okay. Cool. That one's not bad. And if we wanted to sketch our vector, this should make sense because when we go to sketch it, we can sketch 110 approximately, right? Second quadrant up here somewhere a little bit past 90. We can sketch a length of 5. Which would be units of 1-ish, 2-ish, 3-ish, 4-ish, with a little bit more 5-ish. Okay, there's our vectors in terms of 110 and 5. What does our negative 1.710 and 4.698 show us? You go negative 1, negative 2 would be a little bit before. There'd be our negative 1.710. And our positive 1 and a 2 and a 3 and a 4-ish, and it's a little bit more than 4-ish. So our components tell us another way of doing it. But they both end up at the same place. They both end up at that vector in the second quadrant that's going northwest, more north than west. Okay? Now, the whole adding 180 or adding 360 is if they give you something else, and if instead they say, hey, let's go ahead and find the magnitude and direction of, let's see what happens when we use our formula. Now guys, I'm going to make the vector a little bit nicer than the one up above. I'm going to do it approximately the same. Negative 2, 5. Can our formulas get us back to about the 5 and the 110 that we just had? I rounded to make the numbers easier. But what if we were supposed to go backwards? Magnitude and direction. Okay, how do we find magnitude of a vector? Triangle. And we can see our negative 2 is going left 2 and up 5. Long story short, Pythagorean theorem, right? We plug in our negative 2 squared plus 5 squared. And some of you guys are like, what on earth are you doing? Kiddos, we're just using the formula. Oh, I wrote this weird, didn't I? I totally wrote this weird. Sorry, I was writing it for section 6.5, where we are not yet. Do vector v instead. And this is specifically the magnitude of vector v. That's better. So we're just using that formula of square root of a squared plus b squared. If we throw that in our calculators, what do we get? That'd be 4 plus 5 is 29, and square root of 29.
5.38516.
Okay, so about 5-ish, right? Remember I rounded, so it's going to be a little bit off. 5.385. All right, so we have our magnitude, and it's about the magnitude of the one up above. Angle, no big deal. Tangent inverse of b over a. 5 over negative 2. You're in degree mode, hopefully. Tangent inverse of 5 over negative 2 will give you negative 68.19. Wait, is that close at all to the angle up above? It's not even in the same ballpark. Wait, it's not even in the same quadrant. So, does this formula fail? Let's see. Negative 68 is down here somewhere, right? Where's my vector supposed to be if it's negative 2, 1, 2, 3, 4, 5? It's supposed to be opposite. Why wouldn't tangent inverse get it for me? Because tangent inverse only works in quadrants 1 and 4. It gives us between negative 90 and 90. So it gave us the one it could. But what do I have to do to the one that it could, the negative 68.11199, in order to make it the one that I need?
Plus 180.
I need to say, you know what, you're on the opposite side, buddy. So make them on the opposite side, add 180 and get 801 sound good? Okay, is that closer to what we knew it should be?
Yeah.
Does that make sense? So when we need to add 180 is when the calculator gives us this one, but we're like, no. We need the opposite guy. Okay, add 180, you have all the information you need. We would add 360 if it gave us negative 68.199, and we wanted it there, but we wanted to go the positive direction instead. Then we would add 360, but that's not the example. All right, that explains the page of formulas. But why on earth is it such a big deal to be able to go back and forth from magnitude and direction to components and vice versa? Because of this. This example says, hey, find the component form of u, find the component form of v, and then find the resultant. The resultant? The overall result, the net force, the vector addition. Oh, why don't we just add them together? Magnitude plus magnitude is magnitude, angle plus angle is angle. No. The only way we've learned how to add vectors is if we have them in components. And guys, long story short, it's going to be way easier to do them in components. Because if you want to see just real fast, if we were to do it the other way, we'd have to take vector u and say, we can't add u until we translate u. And then we'd have to say, hey, the resultant is from the beginning point to the end after adding the two together. Then we would have to say, oh, you know what? Geometrically, we know that vector u is 50. Vector v is 30. We know that this guy has an angle of 30. This guy has an angle of 110, which means the in-between angle is 80. Then we'd have to say, you know what, geometrically, we have parallel lines and a transversal. Why are we doing this? Well, because we can't solve this triangle until we know pieces about this triangle. And we don't know enough pieces about this triangle because we really need to know side, angle, side to use law of cosine. Well, how do we find this side? Well, we got to think about this side. If that's 80, two same side angles and parallel lines transversal in the interior is going to add to 180, so this guy's 100 degrees. Then we can say, oh, law of cosines. So we can say our resultant, our magnitude of u plus v is going to be, let's just call him, for sake of argument, let's call him x. Yay. So x squared is equal to 30 squared plus 50 squared minus, what am I doing right now? Law of cosines. And I can do cosine of 100 degrees. And I can solve for x by square rooting both sides. And that's only the magnitude. What else do I have to figure out?
The answer?
The direction. Stink. Well, the direction is going to be this guy. How do you find that guy? Well, we have to find this guy next, and then we have to subtract from 110. Did this just get really messy? Is it possible with geometry?
No.
This is
It is. You just saw me basically do it. But
In theory.
why does this tell us just to use components?
Because geometry
Just
looks
going
really
to
hard.
addition if you change it.
Because if we can get it in components, for each one, how do we add component form?
Stab numbers.
Oh, you just add down. Doesn't that sound nicer?
Hello.
What is going on and why is someone's phone out? Get it put away and get the sound turned off. Regan would be ashamed that I'm not confiscating and staring someone down. Get it
Mrs.
away.
Regan,
Is
the
a
cell
champ.
phones would be in the back.
During class?
Yeah.
She started that? Go team.
She has little.
Yeah, she has like the
And then
cell
if
phone
it goes
box.
off, you have to go back and walk of shame
She got
and
tired
turn it
of
off.
Wait, how do we get components? Oh, there are formulas.
Oh,
There are formulas. No, it's not that stressful. Wait. Aren't there formulas for how to get A and B?
Yes.
Given magnitude and angle. We're just gonna use those. So A goes first, B goes second, so the cosine one goes first, the sine one goes second. So all we gotta do is go ahead and say, for U, sweet, 50 cosine of 30, 50 sine of 30. Well, that's not bad. For V, we have to do 30 cosine of 110, and then 30 sine of 110. And then to add, well, we just throw them in our calculators. Can't we do that, guys? So we can go ahead and do 50 cosine of 30 plus, make sure you end your cosine or else things will get funny. 30 cosine of 110. Did anybody else get negative 5.930?
No.
Uh-oh.
Got 33. What do you add?
What did I do to
Oh, I did 5 instead of 50.
What do you add on the 30?
50 cosine of 30 plus 30 cosine of 110. Now I think I'm going to match you guys. 33?
Yeah.
Cool. 33.041. And if we do the exact same thing but with sine instead, if you guys are cheaters like me, just go back and change it to sine and change it to sine. 53.191. So we have the resultant, we have the U in component, we have the V in component. So what have we done so far? We've done the component form, check. We've done the, oh, wait, we got the resultant, but what do they want of the resultant? Component form? Oh, ew, they don't want component. Wait, don't we have formulas to get magnitude and direction once we have the number?
Yeah.
Oh, that's easy. So to find direction and magnitude, we're just gonna plug into our formula and get our 33.041, et cetera, squared. Don't round until the very end. Go steal the nasty decimal that you found. Squared. And for magnitude, we're gonna go ahead and say, oh, that was magnitude. For direction, we're gonna go ahead and plug in the tangent inverse of B over A. B is the second number. Don't round it until the very end. I'm just rounding it for sake of showing our numbers. Some of you are already doing the magnitude. I honestly don't know. Does it make a difference as far as possible or not possible in a certain triangle?
Will it be close enough on like a multiple choice to?
Hopefully. What do you get? Did anybody else get 62.617?
I got 58.
Yep, 62.
Perfect. So we have the magnitude. Check.
Yeah.
Oh.
You do get 50 if you do.
I'm talking about for the direction.
And then tangent inverse of the 53-ish one
58.
over the 58. Is that what I'm hearing?
Yeah, 58.
Perfect. 58.153.
Oh, 3.
And we should have the exact same numbers because you're not rounding. Right? Wait a minute. Hold
The
on.
difference is.
Do we need to add 180-ish?
No.
We go over a 33-ish. We go up a 50-ish. What quadrant is that in?
1.
Oh, never mind. That's in quadrant 1. Check. Dun, 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 dun. And we didn't have to do the crazy geometry pictures.
Done.
So is that pretty much all there is to it?
Yeah, but then there's gonna be a section like tomorrow or something.
Struggle. Yeah, that pretty much is. Now the nice thing is, kiddos, for the most part, we're gonna actually
Skip those.
Well, really, yeah, but-
I'm determining which one to skip.
Oh.
Tomorrow we're gonna go over word problems. Now listen carefully. Listen carefully. Tomorrow, Section 6.3 should be totally done up to the word problems. Tomorrow, 6.3 should be totally done up to the word problems. Tomorrow, we're going to cover word problems quickly. It's an important day. Don't miss it. It'll be a struggle if you do. And heads up, do you guys see how many word problems there are?
A lot.
There are 3. One of these 3 types will be on your chapter 6 test. If you learn it carefully with me tomorrow, you'll be good as long as you study it. One of these 3 types, oh, wrong way. One of these 3 types will be on your chapter 6 test. All right, cool kids?
I don't think so.
One of the 3.
And I'm gonna have to call it here.
One of them. Maybe that one, or maybe that one.
Whoa.
Look at all the details.
Text from your mom saying, how's it coming?
Until like 5?
As you guys are chilling, I'm going to start setting up for
Oh, yeah, I
tomorrow.
bet you I do my finger in the ball thing. Here, it's like, go.
By doing things like naming one of them you,
Oh no. Oh.
and naming one of them the.
And this is why engineering is for noobs.
And saying the combination has to cancel it out
They were both
vector
turning left.
G.
So they're both turning down. They're both turning
Oh, that's really hard to do. Let's not do yellow. Vector G.
Oh, wait, oh, they were both turning left. And she just went, oh, I thought you were turning left from opposite, but she swung too far out. Oh my god.
Bye, cool kids. I'll see you tomorrow.
Bye, I'm not cool kids.
You better reach the break.
See, we're too far.
So it should
Yeah.
be bye.
Problems and numbers were right. So I have to look it up. So next time, we'll be done. It's on my list to get done.